Hello, my name is Milos Malik, and I work for Red Hat as a quality engineer. And my area of focus is SELINUX, to be precise, SELINUX policy, SELINUX user space, and sometimes SELINUX the kernel part. Yeah, what I am going to tell you about. So first, I will ask you some simple questions, so that I know what kind of audience should receive, or what kind of audience will the presentation should I adopt. And then we will talk about reasons why this whole presentation, why the talk exists. And then we will talk about some basic principles. I'm sure that you know some of them, but we have to repeat them for you to follow the rest of the presentation. Then I will show you the troubleshooting workflow, and we will talk slightly about documentation. And at the end, I will show you something which is called a SELINUX troubleshooting chart. And that's it. So now I would like to ask you, please raise your hands if you heard about SELINUX before this talk. Okay, great. Do you use SELINUX on your computer? Okay. Do you use SELINUX in enforcing mode? Great. And if you did you file at least one SELINUX bug this year? Yes. And did you solve on your own computer some SELINUX bug this year? Okay, great. So okay. So this conference has a subtitle which says, "Let's talk about complex systems." So do you consider SELINUX complex enough for this conference? Yes. Yeah, as you can see by the numbers, there is a lot of SELINUX rules, a lot of SELINUX types, and modules and whatever. If you see, or if you compare the two columns, like there is RHEL 7.5 and Fedora 28, you will see that they are quite similar, except for the type transition rules. That's maybe a bug. I was also surprised by the number, but that I will talk about this with the developers next week. So this is premature information. But as you can see that, and maybe you feel it, that SELINUX is something complex, and it makes your applications work badly, or they don't work at all. Do you have this kind of feeling? Yes. Yeah, I see. Yes. Okay. So I hope that using this talk, I will help you to solve some of those problems and make your SELINUX experience more fun. So if we look at some statistics, for example, number of bugs resolved. So since 2012, there was about 3,500 bugs resolved in various kinds of Fedoras, and about 2,400 in various RHELs, meaning RHEL 5, RHEL 6, RHEL 7. If you compare the number of bugs resolved in SELINUX policy and compare it to the bugs resolved in user space, you see that there is a quite difference, right? Like 10 to 1. Yeah, sorry, I forgot to tell you what's user space. User space are usually libraries and tools which allow you to manipulate SELINUX state, SELINUX policy, and work with that. So, based on these numbers, I can say that more than 85% of bugs are filed against a SELINUX policy. And that's one of the reasons I came up with this talk 2 years ago, because this talk, the aim of this talk is to help you cope with a SELINUX policy bugs, which are the most frequent. And the talk will give you some guidance how to do that. I also expect that the talk will teach you some new skills, and that the whole collaboration between you, users, administrators, and SELINUX policy developers, quality engineers, and release engineers, that this whole collaboration will improve as a result. And of course, I hope that more of you will keep SELINUX in enforcing mode instead of in permissive or disabling. So, first, some basic SELINUX principles. So, everything has a label. Everything is denied by default. SELINUX policy brings rules, and these rules allow various kind of accesses. Everything has a label, meaning process has a label, file, directory, device, whatever, network port. Everything has a label. These labels are usually inherited, which means that child process inherits the label from its parent. File inherits its label from the directory where it is located in, unless, of course, SELINUX policy tells otherwise. And labels can change during creation or execution. Creation meaning when a new file is created, new device is created, new directory is created, and when and execution means when a program is executed, when a child process becomes existent. Some of you, or maybe all of you, know Dan Walsh, or at least have you watched some of his videos on YouTube. He is a very famous figure in a SELINUX world. We sometimes call him a SELINUX godfather as a joke. And he basically told many times that almost all SELINUX problems fall into one of 4 categories. First category is there is a labeling problem. Program behaves in a different way in comparison what the SELINUX subsystem expects. Third kind is there is a bug in a SELINUX policy or bug in the program you are running. And fourth, of course, is that your computer may be compromised, and the program you are running is doing something else than what you expect. Yeah. If you have questions, please ask immediately. Don't wait till the end. I will repeat your question so it is recorded. Yeah, stop me immediately. So, troubleshooting workflow. Troubleshooting workflow has 5 stages, 5 phases. These first two phases are problem identification and problem analysis. Identification means that we are answering the question if SELINUX is really the cause of the problem we are seeing. And problem analysis is the second phase, and it is about what is SELINUX trying to tell me. So, first, the problem identification. If you want to know that the problem you are seeing is caused by SELINUX, you should ask audit subsystem. You should ask for something called SELINUX denial. There are different kinds of SELINUX denials, but to see them, you need a running audit daemon. You need a tool, ideally Ausearch. Without Ausearch, you have to grep. Using grep, you have to go through log files, for example, systemd log files or audit log files and so on. Sometimes SELINUX denials happen before audit daemon is started, and in this case you will need the message command. What is an SELINUX denial? So I know it is a huge amount of text, but please focus on the red and green parts. These are important. SELINUX denial is an audit message which tells you that something was denied because of SELINUX, and the message has several parts, and in those parts some of them are more important, some of them are less important. So if you focus on the green parts, you will see that there is something called type syscall and type AVC. And also here are these samba control _t, samba _var_t. And so from SELINUX point of view, is samba control _t is the label of the process who was denied some action. Then there is the samba _var_t. That's label of the file where the access should have happened but didn't, because SELINUX denied it. And here the red is map, and map is the operation. It is basically this is permission map, and it is related to mmap operation. So if I read only the green part from the SELINUX denial, it says that a process running as samba control t was trying to map a file with label samba var t, and it was denied. From a user point of view or administrator point of view, if you focus on the red parts, you will see that there was a command samba control smbd ping, and in the denial you will see that there is a map shared and command smb control and path equals varlib samba log names tdb. So from a user point of view, a root, or in this case it is root, root executed samba control command, and using this command tried to find out if SMBD service is running. Samba use this SMB control thing for pinging their services, because Samba is a collection of several services, and the whole command ended up with an error, and that's because SELINUX did not allow the Samba control to mmap the names.tdb file. I'm not sure what is the purpose of the names.tdb file because I'm not a Samba expert, but from the SELINUX denial I get that Samba control should have access to that, but doesn't. And I would say that this is a bug in SELINUX policy. How to find out that, how to find out what is SELINUX telling me? There are several tools to do that. First, if you remember the 4 categories, like it is a labeling problem. So there is a tool called matchpathcon, and this tool tells you if you run matchpathcon and the path, and it tells you what should be the label of the object in the path. Then there is a tool, SE-search. SE-search is a tool which allows you to query a SELINUX policy and to list various rules based on the criteria you put in. Then there is an audit to allow tool. Audit to allow tool has few uses. One of them is if you have a list of SELINUX denials on one side and like you put this list of SELINUX denials as input to the audit to allow. Audit to allow tells you that either some rules, Audit to allow is able to convert SELINUX denials into policy rules. If the rules are already present in current policy but are not active for some reason, audit to allow will tell you that they are already present but not allowed, not active, sorry. The other use of audit to allow is based on the denials, you can generate rules, a new policy module, which allows exactly what was mentioned in the denials. So it is a short way how to allow what was denied. And of course, there are SE alert reports. Maybe some of you know something called SE alert or SE troubleshoot. SE troubleshoot, it is a daemon written in Python. The daemon has more than 40 different plugins, and these plugins try to find out from the denial what happened, and they give you some advice. Unfortunately, it seems that not a lot of people read these reports, which is unfortunate. So, part of the problem analysis, as again Dan Walsh likes to say, that SELINUX is a labeling problem, and we should ask, okay, the access was denied. Is there a label which will make it like possible? In this case, you can see that there is a command line for the SE-search. So this SE-search command is looking for allow rules, because there is -- allow, and is looking for allow rules where the source, meaning the process, and the target, which is the file with the label samba var t, and -p is the permission. So the search tells us if there is an allow rule which would allow a process running as smb control t access a file labeled samba var t using a map operation. And the output in this case is empty, of course, because this is a bug in a SELINUX policy in RHEL 7.5, and I think it will be solved in the next release. Um, SE search is a very useful tool. It basically searches through the policy, and you can use different criteria. You can even omit some of those criteria. Like if you omitted -t sum of RT, the SE search will show you rules where the process SMB control T can map some file, and it would be allowed. As a result, there are some rules, and there are some labels you can use. But as it looks now, it is a bug in SELINUX policy. So if we continue with the troubleshooting workflow, there are 3 more phases. So there is something called conservative solution. There is a radical solution, and if radical solution doesn't help, you have to go to workaround. So yeah, conservative solution means that we will use some of the options that SELINUX offers us to solve our situation. In the conservative solution sense, our best friends are SEManage and RestoreCon. For example, if you want to run SSH daemon on a port different than 22, 22 is a default port, so if you run SSH daemon on port 22, SELINUX will be okay with it. But if you run it on a different port, like 8022, for example, SELINUX will most likely complain, and SSH daemon won't start. That's because we haven't told SELINUX subsystem about this change. To do that, you can use SEManage port. SEManage port, if you remember, I said that everything has a label. So each port, meaning TCP port, UDP port, and other ports, they have labels. So you can basically instruct SELINUX and tell that, yeah, port 8022 is also SSHD port. And if you do that using SEManage port, the SSH daemon you want it to start will most likely start and bind to the 8022 port. Other very common tool is RestoreCon. When we were talking about is it a labeling problem? RestoreCon is a tool which goes based on what kind of path do you supply it. So it checks the labels on the files with the labels that are correct based on policy. And RestoreCon gives you the option like just show me where the contexts are not correct, or repair them. Yeah. From time to time, it happens that some files get incorrect contexts. Could be, for example, if a machine has a SELINUX running and then you disable it, you run for a few hours or few days in the disabled mode, and then you switch to the SELINUX mode, and then you switch SELINUX on again, there will be some files with incorrect labels. And in this case, RestoreCon will help. And I think that using RestoreCon as a preventive measure is also a good thing. From time to time, you will find out that some files have different labels than what the policy expects, and then it is, and now is the place to ask questions. Why did it happen, and so on. So, radical solution. If conservative solution does not help us, we will go to radical solution. Radical solution means that we will modify a SELINUX policy or write a new policy from scratch for our program, and then we will run our program, our scenario with the new policy. Helpful tools here are again audit to allow. Audit to allow is able to convert denials into rules, and it is also able to create a policy module, and the policy module should be loaded using the SE module tool. There is another tool, not very famous, but it has very nice capabilities. It is called SE policy. SE policy can be used to analyze policy. For example, I have a service, NFSD, and I'm interested which ports, which network ports can the service use. So this is a classic question for SE policy, and SE policy will tell you, yes, there is an NFSD _T context, and it can use these ports, and it can use them in TCP and UDP form and whatever. The other thing that SE policy is able to do is to generate policy from scratch. So let's say you have a program. The program, there is no policy for the program right now, but you would like to write a policy for the program. So you can use SE policy generate and the path to the program. And SE policy generate has several options, and some of them are like the program I'm trying to write policy for, is it a user program, or is it a system daemon? Is it some dbus service or whatever? Yeah, and in these situations, SE policy can help you with writing the new policy. So you don't need to write the policy from scratch on your own, but you will start with what SE policy generate offers you, and then you can improve the policy. So yeah, radical solutions, sometimes it seems that everything is solvable using audit to allow. It is correct and incorrect at the same time, because if you see SELINUX denials, and these SELINUX denials contain operations like, if you remember the SELINUX denial with the map, yeah, here is a map in the curly braces. So if you see on that position operations like exec mode, exec stack, exec heap, exec mem, you should ask questions, because these operations are dangerous, and sometimes they point at the writer of the application or at the compiler. Yeah, the application is maybe written in correct way, but the compiler was given a bad combination of options, or other way around. So other permissions, if you see sysptrace or sysmodule, sysadmin, these are Linux capabilities and permissions. From SELINUX point of view, there are also permissions, and these permissions are very powerful. So you should ask a question: is the program really does the program really need to do that? Is it something intentional, or it is just some byproduct, or am I really running, or do I expect the program to do this, but it does, so it's weird. Yeah, so there are other things that you should be you should ask questions about. Yeah. So, for example, writing to modules object T. So, Linux kernel has there are a lot of kernel modules you can load. Some of them are compiled in, and some of them are in the form of modules, and you can load them on demand. If a program is trying to write to files labeled modules object T, you should ask, why is the program trying to write to a kernel module? This is not very common, and if the program succeeds in writing to the kernel module, anything can happen after you load the module. There can even be a kernel module which, after you load it, it disables SELINUX. So basically, kernel and kernel modules are trusted. So if anything is broken with kernel or kernel modules, SELINUX, and I think that no other security layer will help you, because the kernel is already compromised. So there are other operations which are maybe needed, but a further inspection is also needed. For example, if you see that a SELINUX denial contains unlabeled T, yeah. So there is a question. So is there the denial happened because something was unlabeled, and the unlabeled T also means that the context, I mean the label was incorrect, something like unknown, non-existent. So you should ask, yes, I see that my program is trying to access something. Something is labeled unlabeled T. So is there a labeling problem, or is the program trying to work with files? Yeah. Sometimes devices, if you have very new devices and you plug them into your computer, these devices may be not recognized by the kernel, but then they will be recognized by some kind of driver. So these devices can be unlabeled, and it is, I think, a regular case with new devices. And this is okay, but should be at least filed as a bug for SELINUX policy. Then there are like other permissions, other problems like duck read search, duck override. Do you know what duck override means, or duck read search? Please raise your hands if you do. Okay, so I will explain. So duck override and duck read search. So there is a sequence in which kernel checks if a process is should be allowed to access. So first, kernel checks if Unix permissions are satisfied. So if the process is running with some user group and so on, and if it can access the file or directory, comparing the ownership, group ownership, user ownership, and so on. It sometimes happens that this is incorrect. I mean, the process should not be able to access the file, and as a result, the SELINUX check, which is the second in the sequence, should not be executed at all. But there were some changes in Linux kernels recently, and before that it was switched. So the problem was the SELINUX checks were first, and then there were the user group others checks. So but I think that this will be solved. I think kernel 4.16. There were some changes in this sense. Yeah, I would like to draw your attention to the documentation. There is a lot of online documentation for SELINUX. As the best, I think is the SELINUX notebook, the 4th edition. But all major Linux distributions, they have their wikis devoted to SELINUX, to finding, solving SELINUX problems. So please, or maybe I should ask, who of you has on your computer CentOS? Please raise your hands. Okay. Debian? Okay. Gentoo? Okay. And RHEL or Fedora? Okay, great. So the first two guides, a SELINUX users and administrators guide and the security guide, they are accessible. They are made for RHEL, but they are accessible and should be very helpful for other distributions also. And of course, there is the construct of mine, a SELINUX troubleshooting chart. So don't freak out. I will show you. So is this? Yeah, I expected face expressions like that. So the chart maybe look complicated, but that's only because all the steps, all the basic steps are placed into one picture. I'm sure that the troubleshooting chart can be presented in a better way, but I don't know how to do that. And I'm looking for some ideas and comments about how to do that. So if you have time, take it as your homework, for example. If you had time, please follow the troubleshooting chart once you find some SELINUX problem. And I'm interested in what your results are. If the troubleshooting chart really helped you, if you got stuck, even if you think that something is missing, please tell me, write me an email, or this chart is available on github.com. It is called a SELINUX troubleshooting chart. I'm sure you will find it. And please open issue if you find a situation where the chart did not help you. And now is time for questions. Yeah. Mm-hmm. It will be partially. If the SELINUX policy upgrade caused SELINUX denials, either SELINUX, AVC, user AVC, SELINUX error, or user SELINUX error, you should be able to follow and solve using this. If the upgrade messed the machine so much that SELINUX denials were not logged as a result, then the chart won't help you.
Okay. Let's say I'm preparing another root file system using DNF install root property. How do you restore correct labeling on that? Because after the installation, the labeling is always messed up. And
Yes.
the restore con doesn't work in the chroot, so.
Okay. Yeah, you can. SEManage tool has subcommand called fcontext, and one option to the subcommand is -e, and -e says equivalence. So you can using SEManage fcontext -e, you can say that some tree is equivalent to another tree. So you will use SEManage fcontext -e, and you will tell that this change root or this environment you are installing, like somewhere in /tmp some hash, is equivalent to root. And after SEManage fcontext -e and doing a restore con, the restore con will restore the labels as if they were placed and they were started at root. You can, using SEManage fcontext, do a lot of these equivalences. For example, some of Red Hat software collections or some third-party products, they are not installed to /user, but they are installed to /opt and this kind of. And in these cases, the equivalence is very helpful.
Okay, and second, how to make sure that auto-labeling will wait for the all mount points to be fulfilled? Because it happens that when I use auto-label, it kicks in too soon in the booting during the booting process. So I can end up with not completely relabeled file system.
Okay, I'm afraid I don't know the answer to that. Sorry.
Okay, any more questions? Okay, you mentioned about a few tools. For example, policy. Could you tell if the set sebul also I use the tool? Is that good practice to use it instead of, for example,
SEManage boolean, for example, or like this. Yeah, I must admit that there is a lot of SELINUX tools, and some of them do the same thing. For example, set sebul, which allows you to disable a boolean, and you can choose between disabling temporarily or permanently. Temporarily means that after a reboot it will be again the same. It will go away, and if it's permanent, the setting will survive reboot. So from my point of view, set sebul and SEManage boolean do the same thing. I mean, to be correct, set sebul -p, that's the permanent thing, and SEManage boolean, they do the same thing. They change the boolean in a permanent way. Of course, there are other tools like SE status. SE status tells you that you have a policy which is targeted, it is this version, and you have MLS attributes enabled and whatever. So there are there are a lot of tools. There are some historical reasons, because they the tools were started as simple projects, and then they somehow were joined, or the functionality joined other tools, and so. Yeah, I heard that some users see that as confusing, and I must admit that, yeah, maybe we should have maximum one tool for one thing. Yeah.
Okay, thank you.
Okay, anything else? Okay, thank you, Milos.